Okay, now that we've talked about domain and range and the two different notations we can use to state the domain and range, set builder notation and interval notation, let's look at a few graphs and see if we can determine what the domain and range is by just looking at their graphs. Now, when I look at a graph and I'm looking for domain and range, I'm thinking domain is my x's, and I want to follow the path on the x, along the x, that means from the left to the right, and I want to see what x values I would end up walking along if I'm looking for the domain. Same idea with the range. On the range means y's, I would go from the bottom to the top, and if I'm walking along that path, what y values would I walk across? Okay? So if you look at example number 2 has 4 separate dots. If I was trying to walk across this path, I would have to hop from dot to dot to dot to dot, 4 of them, right? As I'm walking, and if I'm walking left to right, what x values would I hit? Well, I would hit x equals -3, I would hit x equals 0, I would hit x equals 1, and I would hit x equals 2. Those are the only 4 x values that I would hit. So that would be my domain. My domain is -3, 0, 1, and 2. And because there's only 4 of them, I can go ahead and just list them out like that instead of doing some sort of an interval notation. All right, what about range? Range again means y's, from the bottom to the top. If I was hopping from dot to dot to dot, what y values would I hit? Well, it looks like I would hit -5, then -4, then 3, then 4. So that's my range. -5, -4, 3, and 4 would be my range for those 4 dots for that graph. Okay, what happens if it's not just dots? So look at example number 3. What happens if there's an actual path? Well, think about your domain as your x's. If you start at the very left point and you follow the path, what x values do you end up walking along, hitting? Well, it looks like I started at x equals 6, and there's a closed dot there, so I want to make sure that I include -6. And then I walked along the path and I hit every single x value until I got here and I stopped at x equals 2. And I didn't include x equals 2 because of that open circle. So it looks like my domain in interval notation would be -6 with a closed bracket because I want to include it, all the way to 2 with a parenthesis because of the open circle. So -6 to 2. Or if I write it in set builder notation, it would be the set of all x's such that x is greater than or equal to -6, but less than 2. You notice my inequalities there? Greater than or equal to -6 because of the closed dot, and then less than 2 because of the open dot. So you could write it either way. Make sure that you practice both ways. All right, what about range though? Remember, range means from the bottom to the top. So how low do you ever get on this path? Well, the very lowest point on this graph looks like this y value right here, which looks like what, -13? It looks like we go down, we touch it, and then we go back up, 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 up. What's the highest we ever get to? Well, it looks like the highest we ever get to is that number in there. So it looks like the lowest x value hits at -13, and then the high, and it goes all the way up, and it hits every x up until we get to, not x, every y until we get to 5, but we don't want to include 5 because of the open circle. So in interval notation, I would say including -13 all the way up to 5, but not including 5, so parenthesis. In set builder notation, I could say the set of all y's such that y is greater than or equal to -13, but less than 5. So again, domain left to right, range bottom to the top. All right, let's practice a few more. Look at example 4. Example number 4 looks a little bit different because now we have arrows. Those arrows indicate that we're going to keep going and going and going. So if I'm looking at domain, remember domain is left or right. If I were following this path and I were continuing to go left, 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 wouldn't I keep going left, 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 up, 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 left, left, left forever? And so I would approach -infinity, right? And then I would go down and I would go right and I would go right and I'd touch all of these x values and I'd keep going right, 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 because that's what the arrow means. I'm going to keep going up and right. And so it looks like every single x value I would walk along, I would hit every single x. So my domain looks like it's going to be -infinity to infinity. Or I could say all real numbers. Now what about the range? Remember, range means lowest to highest on the y value. So from the very bottom up to the very top. So what's the lowest you ever hit if you are walking along this path? Well, it looks like the lowest we ever get is this point right here, which is y equals 0, right? And then it looks like I would go up, 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 up from there, and I would keep going up and out because of those arrows. So it looks like my range would be 0, including it, because it looks like it goes down and touches, and then it goes back up. So 0 to positive infinity. Or I could say the set of all y's such that y is greater than or equal to 0 if I wanted to do set builder notation. All right, look at number 5. Number 5 also has arrows, but in addition to the arrows, it has this circle or the hole, right? All right, think about domain going left and right. So it looks like this is going to go left, 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 left. It's going to continue going. If I were walking along it, I would hit all of these x's, ooh, but I would fall into a hole here at x equals -3, right? And then I can jump over the hole and I can keep going and going and going and going to the right, 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 and I would keep going forever. So it looks like all of the x's work except for this hole at x equals -3. So in interval notation, I can say from -infinity to -3, don't include it. And then again from -3, don't include it, to positive infinity would be my domain. Or in set builder notation, I could say the set of all x's such that x just cannot equal -3. It can be anything else except for -3. All right, what about range? How low does it go? How high does it go? What's the lowest x value? What's the y value? What's the highest y value? And is there any y values that aren't included? Well, it looks like it keeps going low, 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 low because of that arrow. And it goes high, 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 high because of that arrow. But isn't there that hole there? And so make sure that we don't include the y value here of -5. So it looks like all the y values are included except for that one, -5. So my range would be -infinity to -5, and then from -5 to infinity. They might want you to use the union. They might want you to use a comma. Some have you even use an and sign. Anyone would work. All right, if I was doing set builder notation, then maybe I would say the set of all y's such that y just isn't equal to -5. It can be anything else, just not -5. All right, make sure you practice looking at all different types of graphs and being able to write the two different notations for domain and range.